I'm going to talk about the challenges in the development of point-of-care diagnostics for low-resource settings as in developing countries primarily, even though if you really think about it, pretty much any healthcare systems is resource constrained, and I think with the cost pressures that we're all facing, reducing cost and increasing simplicity of diagnostics and other medical tools is a critical thing that we have to apply across the board. So today, this talk is a little bit about global health and the role of diagnostics within global health. What I think is the sort of the transformational potential of point-of-care diagnostics in low-resource settings. Then really one of the big things that came out in the last few years is sort of the major new health threat in developing countries, really everywhere, but also in developing countries, and somewhat surprisingly also in developing countries, is the emerging diabetes epidemic. Diabetes at this point is one of the biggest causes for morbidity and mortality in developing countries, and that's really something that is becoming more widely known now, but it's really, a few years ago, it was something that people really didn't pay any attention to. And then the last thing is, I hope I'm going to get to this, but is this something that's completely separate, but I think is worth discussing maybe in this group here, and that is setting standards for point-of-care diagnostic platforms in low-resource settings. And that's something, standards in diagnostics is not something that has been very successful in the past. And the Bill and Melinda Gates Foundation is taking another run at it. It's going to try to do what they can to put certain types of standards in place for diagnostics, especially for low-resource settings. And I'm going to talk a little bit about what the potential advantages could be, some of the pitfalls, and so on. So what I'm not going to talk about is what we actually in my group mostly do, which is really work outside of diabetes. Diabetes is kind of a new thing, and I'm very interested in it, and that's why I'm talking about it. But most of what we do is really infectious diseases at path. And so if anybody's interested in that, please let me know, and I'd be more than happy to talk to you afterwards. There's lots of things I can talk about there, but today is mostly about things other than infectious diseases. So diagnostics comprise 3 to 5% of healthcare spending, but influence 60 to 70% of healthcare decisions. This comes out of a sort of a diagnostics industry pamphlet, so you would expect that they would say that. But at the same time, it's probably true, and I think what it practically means is diagnostics is really a good deal. Sometimes you hear about, obviously the high cost of diagnostics in some specific areas, but overall, especially in vitro diagnostics is really not a very expensive component of medicine in general, and it has very wide-reaching impact. And what diagnostic devices, and I use diagnostic devices in the broadest possible sense, and I'm sure a lot of people here would disagree with me because that's not diagnostics, that's true, but what I mean is tests of one kind or another. They are used across medicine in a whole bunch of areas. And so obviously what I'm talking about is tests used in epidemiology, tests used, so what, in an ideal world, I guess this circle sort of describes how, I guess, decisions might be made in an ideal sort of disinterested, objective setting, where you start with epidemiology, try to figure out what's going on in terms of presence of diseases, pathogens, toxins, and so on in the environment, in the population. Go from that to some kind of health prioritization. Follow that on with individual patient testing to find out which of the people in that population actually suffers from any of those things that you find. Then do your treatment and prevention with some kind of drug, some kind of therapy that frequently, again, needs to be tested because drugs need to be tested, followed up, and so on. Then that is followed by treatment monitoring in an ideal place, verification of cure, and then while you're doing all these things, you have to perform QA, QC on the diagnostics themselves, both on the devices as well as on their use. And so there's a role for tests of one kind or another in many of these places outside of the sort of core area of diagnostic that we usually think of when we say we perform diagnostics. So for those of you who are not familiar with PATH, we are a relatively large program at this point, NGO headquartered in Seattle. We have about 1,000 people worldwide, with about 20 some country offices, primarily in developing countries, but also in DC and Geneva and so on. But for the most part, the offices are in developing countries. And we are funded by foundations, it says here. Of course, it's really mostly one foundation, and that's the Bill and Melinda Gates Foundation. They cover most of this, but there's other foundations also that fund us. And the U.S. government, in the diagnostics group, there's actually quite a bit of U.S. government funding. Because we're more researchy, so we do a little bit more NIH grants and so on, and also a little bit of DARPA and other things. Then there's also some other individual donors and investments and so on that make up the rest. What does PATH do? And it's sometimes a little bit hard to explain what the role of an organization such as ours is. I mean, we are an organization that tries to improve the health of people around the world. Well, that's sort of a generic kind of thing. But what we do is we form what's called product development partnerships. And those are really sort of tools, organizational tools, if you will, that engage the private sector to create public benefit by mitigating risks. What that means is we might form, I'm going to give some examples for that, but ultimately what it means is companies want to, if you look at this diagram here, a company wants to develop a product that maximizes the potential return and minimizes development risk. So they want to be down in that right lower corner here. Most of the kinds of diagnostics or any kind of health product that PATH is involved in really tends to be in that, certainly in that sort of upper left corner somewhere with relatively high development risk. These are complex kinds of devices, have to work in very difficult circumstances. At the same time, the return is usually not as good. So why would any sane company actually want to go there? Well, the way we get them to go there is by reducing their risk so that we essentially move that line here. And we are trying to make it attractive for the private sector, despite the fact that it's difficult to tackle these projects. And so in the PATH Diagnostics Group, we work across the diagnostics development spectrum here, from concept development, really from all the way from invention to diagnostics development, transfer, implementation, and really sustaining the market for diagnostics. That's something that's actually a little bit different from the private marketplace. A lot of the times you have to actually work actively to keep things available, keep them in the market, because they are not such obvious products that would stick around. So we also do other things such as capacity building, and lab evaluations, field evaluations, and so on, and training. I'm going to mention that at the end through our point-of-care diagnostics center, also in collaboration here. Karen is here, who is on our center, Karen Stevens, and so we have a very active training program for diagnostics developers for point-of-care diagnostics for low-resource settings. So in developed countries, point-of-care testing is something that's performed. It's defined as something as testing that's performed near at the site of the patient care, with the result leading to a possible change in the care of the patient. Well, that's obvious. But what's the key objective? Generate the result quickly to influence treatment. Point-of-care testing generally is designed as an adjunct to central lab testing. It's not a replacement. It's not like somebody sets up a clinical facility and solves most of their problems with point-of-care testing. It's something that you do if you have to, but you don't do it if you don't have to, pretty much. And I think part because of that, but the reality is, with very few exceptions, point-of-care testing is not something that's transformational for patients. It doesn't, as a patient, you don't. It's not that you're generally not aware of the idea of point-of-care testing. I mean, exceptions, of course, are diabetics, who are very much aware of the value of being able to do their own testing or being at a place where testing can be performed right next to them. But most patients, with some exceptions, probably don't care. And so that's the situation in developed countries. In developing countries, point-of-care testing is a very different story. Point-of-care testing in many ways is pretty much the only testing there is. While there are certainly reference labs in developing countries, most testing is performed quite near the patient, is performed while the patient is waiting. Because if you don't perform it while the patient is waiting, the patient is going to disappear, and you won't have a way to follow that patient or contact the patient. Patient might not come back. There's a lot of reasons why this would be difficult. So, I mean, the pictures I'm showing here, may look a little extreme, and in some ways they are for labs, because of course they're very nice labs, and I've been to very nice labs in developing countries, and I didn't put those up because they look exactly like labs in our facility here. So those are not the ones that are so interesting in a way, but these are also real labs. And testing can happen in outside settings, in field settings. They can happen in labs that don't have a lot of infrastructure, might not have climate control, might not have sufficient power, or at least continuous power, and so on. So that, of course, all defines the kinds of tests we can perform in developing countries. So what I think the transformational opportunity here is for point-of-care testing in developing countries is really, maybe it's best understood through sort of an analogy with mobile phones. As many of you know, mobile phones are ubiquitous in the world now. Even in the poorest neighborhoods, you will find people having at least one phone. Some of them have more than one phone, and they may have very dire circumstances in their lives otherwise, but they almost certainly have a phone. And the reason is because it's cheap, it works well, and it has absolutely surpassed landlines as a standard means of communication. Nobody in their right minds, if you were to start from scratch, would now put in a landline system. And so if you think about it, in some ways, landlines might be the equivalent of a sort of a central lab-based system. And I know, I mean, I'm probably courting some controversy around here, but notwithstanding all the advantages that a well-managed, centralized lab facility can offer, but it is a complex, expensive proposition, and it requires a lot of infrastructure. If you don't have that infrastructure, you have two choices. You can either build up that infrastructure to run something like a central lab, or you could say, I'm going to give up on the idea of central labs and do everything in point of care. And then maybe with the exception of having a reference lab somewhere in a capital city for some specific either training purposes or for some very specific kinds of diagnostic testing, but not for routine testing. And that, of course, is an open question at this point. Can this happen or can this not happen? There's some good reasons why it might not happen. And one of them is the analogy is really not a very good one, because it's a very different thing if I send electrons around wirelessly or over wires, or biosamples. I mean, that's, the biosamples need to be treated very differently, and so it's very much harder. And then the other thing is QC, QA. If you have a totally decentralized system, maintaining QC and QA is going to be a huge challenge. And that's something I don't think is generally, even theoretically, worked out at this point, how that would be addressed. So those are really the big issues that need to be tackled, in addition to coming up with all the little gadgets that are at this point being worked on. So what are the advantages and challenges for point-of-care testing for developing countries? So if you look at what's difficult, well, in general, point-of-care testing costs more per test. Pretty obvious. It's you don't have the economies of scale, and you need to put in more complexity, if you will, into the device in order to address some of the QC/QA issues that you would normally address through better, more educated personnel and bigger machinery and so on in a central lab. You have the quality control risk. Challenges for point-of-care testing might be the availability of even moderately trained health workers. It's not a given that you would find people who could actually run those things, even if those things are very easy to run. even so, there's still a lot of ways to do, for example, to run a strip test the wrong way. It has happened. It happens all the time. Test procurement and distribution. If you have to send tests to 1 or 2 or 5 big laboratories in a big city, that's one thing. If you have to send lots of tests to lots and lots and lots of small providers somewhere, it's a totally different story. And to do that in a reproducible way, just to work out the logistics for that is hard. There's certainly performance limitations. Telemedicine can supplement some of those issues. So certainly if you have trained people working through telemedicine with the local providers, that can help. But at the same time, it can also disempower local people if they don't actually make any decisions based on the results they see, or if they don't necessarily really understand them. So I don't think you would want to build up a whole system based on telemedicine. That is a risky proposition in itself. And of course, sometimes central laboratories is really the only way to do a certain test because no point-of-care test is available. And that's probably true for most tests at this point. It's actually a relatively small minority for which you can get good point-of-care tests at this point. But of course, there are big advantages. One of the main ones are the lower startup cost. If you don't have a centralized infrastructure, many countries would not have the resources to build up a good infrastructure for central lab testing anywhere in the near future, whereas they can set up a point-of-care system, at least for some settings. It's more flexible. You can address the different needs for different settings by customizable solutions and so on. It does empower local healthcare providers. If they have the means to actually provide good answers to their patients, that increases local knowledge, which I think is helpful. You need minimal infrastructure. You can have very rapid turnaround of test results. And sometimes point of care is really the only way to go, because what if you are in a place where it would take 2 or 3 days to send a test somewhere, and that's too long. So sometimes point of care testing is really the only way to solve a particular diagnostic problem. And how this would sort of practically work, and how this does work in some cases, even though that's sort of an idealized scenario here, is that really you have some advantages by going local with diagnostics and with healthcare in general. And maybe the biggest advantage is it's sort of going back to a kind of like a village doctor model, if you will, where yes, you may miss out on some of the specialization and technology and so on, but you have a few real advantages that are based on familiarity. You have sort of local knowledge of disease history, epidemiology, family history. You have, as a community health worker, essentially you have nagging power. You can get people to do certain things. You can get them to go to the doctor. You can if you look at chronic diseases especially, that's a critical element to keep people to stick with a plan of some kind. What's needed, of course, is right now the model pretty much exists, but it exists without diagnostics, or with minimal diagnostics. There may be a few strip tests that might be usable in a setting like this, maybe a microscope, but that works half the time and it doesn't work the other half. So this is largely an IVD-free system right now. Telemedicine is starting to be implemented in some settings sort of through semi-private parallel healthcare systems that operate in parallel to public healthcare systems primarily. What's needed also that hasn't been implemented but I think is needed is a proper health record keeping, health histories for people through biometric image identification and health history tracking. Of course, better training is always needed, and so a system like that can certainly, I see, could certainly be built, and could be built probably more cost effectively than a full-blown healthcare system like the one we have here. And you would probably still need higher level labs and higher level clinics as sort of fallback so secondary infrastructure environments, but not the primary way that people would get healthcare. So If we develop when we develop a diagnostic path, as I said, we remove the risks for all partners. That could be technical risks such as we perform R&D, we do tech transfer to diagnostics developers and manufacturers. We support other diagnostics manufacturers both through on the design side as well as on the manufacturing and on the technical side. We do a lot of market work. So a lot of the issues that, say, a startup that has an interesting technology for low resource settings, what they might face is that they have absolutely no idea who would want this device, who could pay for it, who they would sell it to, is there a big enough market, things like that. We can help with that. We can tell them for many settings what's called a proper target product profile might be. We can reduce clinical risk through lab and field evaluations. We have a lot of standing clinical test sites and the country offices that can help with that. And maybe the biggest issue that we can help with is uptake. Once you have a test, there's a lot of things that need to be done to make sure that that test actually makes it into the field. So we can help with establishing the right contacts with the big donor organizations, with the big vertical programs such as the Global Fund or PEPFAR or so on. A lot of the times you have to get through certain hurdles to be able to work through those big consortia. And we know some of those mechanisms, how to do that. So by doing all these things, we can help. We can essentially make it less risky for a diagnostics developer to make a product for developing countries, and because of that, more attractive. This is an example, a simple example of a test. It's a strip test for Chagas disease. Chagas is regional disease. Has about 100,000 new cases, so it is a neglected disease, but it is among the neglected diseases, it's one of the sort of bigger ones. And there are good drugs, and there is a good ELISA assay, but the ELISA, of course, needs a lab. The disease happens primarily in rural areas, quite far away from the city. So there is an access issue here. So what we developed or we put together was this product development partnership in which we partnered with the developer of the ELISA or the manufacturer of the ELISA to develop a strip test version of the ELISA. And then we transferred the strip test to a distributor and manufacturer consortium comprising bioMérieux and Fiocruz. Fiocruz is a parastatal in Brazil, and bioMérieux is a big diagnostics company. And so Fiocruz makes the test now. The test is distributed between the two in different places, and so it's at this point it's in field evaluation stage, and the whole thing was accomplished with really relatively little money. So $400,000 worth of grant funding. That's for a whole product is actually fairly inexpensive. Most of the time it costs more than that. And because of all that, the investment of the various partners, be it bioMérieux or Fiocruz or Lablemos, was all relatively low. And so it became a reasonably attractive proposition. It's never going to be a blockbuster product, but it'll be a product that will make it to the marketplace. And that's a relatively typical example of how we would work. So all of you, or many of you probably know the archetypical diagnostic tests for low resource settings, and that's really the rapid diagnostic strip test. And in many ways, a strip test is an amazing tool that does a lot of things we expect from diagnostics and does them exceedingly well in a very, very small and very inexpensive package. It does sample preparation, it does sample fluid movement, essentially has a built-in pump. It does signal visualization, you don't need a detector. It has an internal control built in. It contains the bio-waste, so it doesn't bleed back out. And the whole thing costs you quite a bit less than $1. Typically, you can cost of goods for those things tend to be now in the 20-cent range, thereabouts, in most places. Some products based on lateral flow strips cost about 60 cents, malaria, the best-selling malaria strip test at this point costs about 60 cents per test. So these are extremely low prices for any kind of diagnostic test. I'm sure you're familiar with the reimbursement rates for regular diagnostics, so this is at least a factor of 10 below that, probably more. There's, of course, drawbacks. I mean, strip tests lack sometimes in sensitivity and specificity, not always, because for things like HIV strip tests, they are very good for the most part. I mean, not blood bank good, but good enough for almost any other application. It's a little difficult to provide a quantitative result. So they work great for infectious diseases and for things like pregnancy, but they don't work very well when you need to have a quantitative result. So for a lot of chronic diseases, for blood chemistry and so on, it's difficult to do. Once you have to adjust levels based on a parameter, strip tests are really not ideal. There's lots of user errors because the users tend to be untrained people. That's part of it, and also because of some inherent issues with the test itself. There's a very low barrier to manufacturing, and that's probably maybe the single biggest risk, the single biggest issue we have with strip tests. Anybody who has $10,000, $20,000, $30,000 can set up a rapid diagnostic strip test manufacturing facility, and people do all the time. There's literally hundreds of diagnostic RDT manufacturers, and there's about 100 or so malaria tests on the market right now, different kinds. Of those, probably only 15 to 20 are any good. The other ones are really very problematic, with some of them being outright fraudulent because they have essentially no reagent on them. So you have the whole range. You have some very good ones, some very bad ones. And of course, it's not inherently clear. Record keeping and reporting is not built in, so that's something that's up to the user. And of course, a lot of the times it doesn't happen. So what, I guess, a path and in this whole field, what people are really looking for is to build something. I mean, the strip test is still in many ways ideal because it is simple and cheap. But what we want is, of course, capabilities that are closer to the performance of a full diagnostic lab, but still as simple and as cheap as strip tests. That's really sort of the ultimate vision that a lot of us in this field have. And what usually comes here is a big spiel about nucleic acid testing and all kinds of other diagnostic assays that PATH works on that I cut out for today because I wanted to talk about diabetes. But really, that's what the majority of the global health diagnostics field works on at this point. However, and I can tell you lots about that part, but what I wanted to talk about today is really something else, and that is diabetes is an enormously growing problem in developing countries. It's an enormously growing problem everywhere, but it's stunning in a way it has grown in developing countries, and I'm going to talk a little bit about why. But first, before we get started here, I talked before about 3 to 5% of healthcare spending for diagnostics, but it influences 60 to 70% of healthcare decisions. In terms of healthcare funding or research funding, chronic diseases in developing countries comprise quite a bit more than 50% of morbidity and mortality, actually more like 65% at this point. But they receive only 2% of the total R&D funding. So for example, all of the Gates Foundation at this point spends practically nothing on chronic diseases. Almost all of it goes into infectious diseases. For probably good reasons in the past, no question, but I think things are changing and I think they need to be addressed. Here are some of those numbers, and they're really quite stunning. India and China has now, or will be having, about 100 million diabetics very soon each. And if we think in the US we have a diabetes problem, if you look at those numbers here, that's a different scale. Here, just as an example, in India, the kinds of prevalences that people have, and that's the current numbers, and there's new prevalence studies going on that I'm sure is just going to push it further up. But you have things like in Chennai, for example, where I'm going to be in about a month. We have a diabetes study there. You have 18.6% prevalence. That's just enormous. And why is that? Because that's kind of, the first thought that everybody has is, well, it must be fast food, must be, changes in nutrition and all this, and maybe mobility and so on. And I'm sure there's a lot of that, but there's a few underlying causes that have little to do with that. For example, there's a few things that are certainly controversial, but have been stated by various opinion leaders in this field. For example, that gestational diabetes appears to cause type 2 diabetes eventually in the offspring. Then famine causes type 2 diabetes, or diabetes in general, both gestational as well as type 2, because essentially, I'm not a clinician, so I'm just repeating what people tell me, but essentially the pancreas doesn't develop very well under malnutrition conditions, and because of a not well-developed pancreas, you're more likely to develop diabetes later on. Low birth weight is correlated very strongly with diabetes, regardless of cause. So all kinds of things can cause low birth weight. Infectious diseases, malaria, and so on can all cause low birth weight. And because of low birth weight from some unrelated cause, the people go on to having much higher risk of diabetes later on in life, especially if adequate food supply becomes available later. Obesity and lifestyle are much more loosely correlated with diabetes and gestational diabetes in developing countries. They are correlated, and that's why we're seeing some more of it now. But the obesity, if you overlay obesity curves and diabetes curves, diabetes far outstrips obesity increases. In some places, like in Cambodia, for example, where they have a real diabetes epidemic, the majority of diabetics there are not even overweight. They're more or less absolutely normal weight people. There's also risk factors that include comorbidities such as TB and HIV. TB is well known at this point. Something along the lines of 50% of all TB patients will also have diabetes at some point. So that's another risk that's associated. Diabetes cannot be considered exclusively a disease of affluence. If you look at those curves here, you see that over time, while lower income people had lower prevalence of diabetes, now that really has approximated to the same level. So regardless of income, people have diabetes. Complications, in fact, is even worse with lower income people because there's less treatment, of course. So they're more likely to go on to complications. So what we have done what we've engaged in primarily in the diabetes area is we're working on the screening end of things. We felt that before you can do a lot of one of the primary issues that people don't know they have diabetes, and before they even know they have diabetes, there's not much you can do. So we looked at the current screening modalities and found a few things that we thought at PATH and with our partners we can possibly address. So the goal for, let's go here first. In general for diabetes, and I'm sure most of you know this, but there's a few different areas in diabetes where diagnostic tests are needed or medical tests are needed. First in screening, there's a few the methods that are out there are fasting, plasma glucose, the oral glucose challenge test, some risk factor screening through questionnaires and biometrics, and people work on new biomarkers in this area as well. For diagnosis in general, what is needed is, or what is currently being done is generally oral glucose challenge test and low-cost, and HbA1c is now an accepted method of initial diagnosis, WHO recommended at least. But there's some issues with both of those. I'm going to talk about those. There's additional. Of course, once you do take insulin, you need you need to constantly monitor blood glucose in various ways, and then there's lots of different methodologies. And then in addition to treatment monitoring, you need to monitor treatment adherence and efficacy, and that is done generally through A1C measurements, and then some of the newer methods such as glycated albumin, fructosamine, and some other biomarkers that people are looking at. So what, in terms of screening though, what is being done in developing countries is none of those methods. It's primarily random blood glucose testing, and that is really a very it's random. I mean, it's got random in its name, but there's something to that. I mean, it's more or less it's loosely correlated with diabetes risk. Fasting glucose testing is a lot better, but fasting glucose requires that people actually know that they have to come in fasting. It doesn't allow for opportunistic screening, which would be the best screening modality. You really want to screen when people come in, not when you have to prepare them for that. Urine glucose strips actually are a surprisingly good way to screen the severest cases, even though urine glucose tests have pretty much been forgotten in most places. But they do work quite well, because if you do show up positive on a urine glucose test, you have diabetes pretty much. You can be guaranteed that you have it. A1C would in principle be a wonderful method for type 2 diabetes, but the downside right now is the individual test costs, at least in developing countries, tend to be in the $10 to $15 range, and that's just really out of the question in most places. That's just not a practical test. And for gestational diabetes, we have an even bigger problem, because really the only method that currently works for gestational diabetes is oral glucose challenge test. What we need is a method that can determine if somebody has a high risk, is at high risk for gestational diabetes without fasting. That would add an enormous number of people to the pool of people that could be screened. So we've looked at a few methods, and these are some of the methods that we are evaluating at this point, both in the Chennai study as well as we'll start soon in a Tanzania study. So first, this is a class of readers that looks at advanced glycation end products in skin. And I want to make very clear this is different from all those failed tests that have tried to measure glucose through the skin. This is not what this is. Many tests have tried to measure glucose through the skin. It's never worked, and it may at some point, but maybe not. This is different. What you're looking at is products of essentially elevated blood sugar for, as soon as you have elevated blood sugar, glucose starts to glycate all kinds of proteins, including skin proteins. And this is what you're measuring here, because these products tend to be autofluorescent. So if you shine a light on it of certain frequencies, you get some fluorescence back, which is what you can measure. And there's two companies out there. These are Diagnostics and Verilight, one US-based, one in the Netherlands. Both of those do something quite similar. They have algorithms that tease out from a relatively complex signal. They tease out the signal that's directly correlated to diabetes risk. And the big advantage here is that both these devices, even though they look relatively complex because they're machine, but they don't require disposable. All you need to do is you put your hand on them, and you might have to wipe off the surface, but that's it. There's no disposable need, there's no calibration, no correlation. There's really nothing complicated about them. So we are evaluating those devices right now, and one of the interesting things that is we will have to deal with as a global health organization is how are these companies gonna make money off that? And how are they gonna be successful with that? Because right now, if these companies, their business model is based on something completely different. What they wanna do is they wanna put a counter in there and they get a payment every time somebody runs a test. So which is the equivalent of buying a disposable, really, for all practical purposes. So the question is how would they be open to an alternative business model in developing countries where essentially you can just buy the device and then it's free to use. It's sort of more or less open source beyond that. So that's things that have to be worked out. A1C, of course, I already mentioned that. There are very low-cost devices, but the thing is here, the disposables cost a lot. They cost $10 to $15. So here we are working with a few startups to see if we could come up with a much lower cost of doing A1C tests. Maybe even without an instrument, maybe just strip test based. That might be the ideal situation. Back to urine dipsticks, as I mentioned before, they have been pretty much forgotten as a tool, but we think that they might, in some settings where you can't afford anything else, they might still be a quite good diabetes screen for high-risk people, and it's worth evaluating them in that context. One of the most attractive and interesting areas for us that we're looking at right now is alternatives to A1C, and alternatives not necessarily for cost, but alternatives for what they really do. A1C measures glycated hemoglobin, which averages really glycation levels over approximately 3 months based on the lifetime of hemoglobin. Other proteins have a shorter lifetime, and because of that would average over shorter periods of time. Albumin, for example, has a lifetime of approximately 2 weeks, so or a little bit more, 20 days, something like that. So you would actually get an average over a shorter time. You would see spikes or bad glycemic control over shorter periods of time. Fructosamine is sort of an average in itself because it averages of a bunch of different proteins, but there is a potential here, and that is to sort of dial in or to compare different proteins based on their lifetimes, based on their residence times. And if you measure a few different proteins from different ranges of lifetimes, you can actually then compare and see how your short-term glycemic control, medium-term glycemic control, and long-term glycemic control is. And that in itself, I think, has value regardless of where you do it, if you do it in developed or developing countries. But of course, our main attraction for glycated albumin at this point is because it would allow you to do gestational diabetes monitoring or gestational diabetes testing without sample preparation, without patient preparation in developing countries. So that's probably the most attractive thing. And we're developing a strip test for glycated albumin right now, and there's a few other companies that have other alternative approaches. So there's a few other, I think, issues that we think YPath should play a role here in diabetes testing in general, and that is there's really a conflict of interest here between what you would get out on the marketplace and what would be needed in developing countries. So right now we know what the existing manufacturers, what the current manufacturers are pursuing. They're pursuing the high-end market in developing countries, and they will eventually make things that are a little bit cheaper, but really they want to address high-value market first. But some things, for example, that are very promising areas of research, they lie in reduced testing algorithms. For example, there is some good evidence that people can be trained to do to use glucose as they get glucose tests, say, for some period of time. Then you reduce the numbers of glucose tests that they perform every day, and while still getting insulin, and then the glycemic control on average actually stays almost the same. So it actually, people can be trained to sort of become more self-aware and listen to know their caloric intake and so on, and their nutritional intake, and can actually be trained to do a better job at glycemic control even without a lot of testing. So that's an area that obviously there's not a lot of interest from the diagnostics manufacturers to go down that way. So these are really some areas that need to be pursued. There's some areas in diabetes outside of testing. For example, insulin needs to be kept cool or cold. There's some technology that might be needed there, heat stabilization, for example, heat indicator marking. And so on. There's a variety of different things here. So the last thing I wanted to briefly talk about today is standardizations, diagnostic standardizations. And there's a big initiative that some of you may be familiar with going on from the Gates Foundation. It's called Grand Challenges for Global Health and Grand Challenges for Diagnostics. And that is done in a collaboration between Grand Challenges Canada and the Bill and Melinda Gates Foundation. And what they're trying to do is they're investing, they're funding 15 or so diagnostics manufacturers, but at the same time they tell them that they have to collaborate. And we are one of the groups that help the Bill and Melinda Gates Foundation at this point to essentially, if you will, invent the rules for how they would collaborate. And there's different areas. There's business standards, there's sample standards, and there's interface standards that need to be defined here. And the idea is really to create open standards and that anybody develop and commercialize assays for those standards and components that fit together. So diagnostics interface standards, there's sort of a general perception that there aren't a lot of standards within diagnostics. And in some ways that's true, but there's a lot of intra-company closed standards. For example, ISTAT tests always fit together. So ISTAT has a standard. Other companies have internal standards. They have integrated other companies and have built assays on their platforms. So they can standardize. It's just that the standards are not shared. One of the areas that the Gates Foundation is sort of working towards is the concept of if you will, a rack, a diagnostics rack that's somewhat similar to the way computers and cell phones and so on are interoperable, where they have components with slots and so on, and where disposables would handle chemistry and fluids, platform units handle mechanics, optics, electronics. The rack handles the overall operating system, power, communications, and there's various device customizations that could be done by the individual manufacturers, and they would make only their component, but they know the interfaces to which they would have to design for. And there's a real advantage here. The real advantage is kind of in three areas. One of them is the Gates Foundation would essentially, together with others, would secure or procure an installed base of these devices. So there might be initially 10,000 devices or 20,000 devices that would be established with a sort of a minimum set of diagnostics. And then manufacturers would have an incentive to develop for that installed base. So there's a commercial attraction here for that. Then a just as important thing, one huge problem that most people are not aware of is the almost non-existent or extremely heterogeneous approval mechanisms in developing countries. So we have the FDA here, but most of those devices, almost no devices that are used in developing countries actually go through FDA approval. They go through local approval of one kind or another. There is no universal approval system. So what really needs to happen is that instead of having to go through all these different approval, country-by-country approval systems, is that something like a more international standard gets established. And it has been tried about 10, 15 years ago. The WHO has established a pre-qualification scheme that really hasn't lived up to its potential. It has not really successfully worked. There's only a few tests that have undergone that. And so an alternative to that would be essentially, instead of coming up with an approval methodology, it's almost the opposite. You come up with a device, and the device becomes sort of the de facto standard that countries would then sign on to. So there could be sort of a quality seal of approval just by nature of being on that particular device. And then of course, the third thing that standards do is it would sort of focus manufacturers, give manufacturers the option or the idea to even go after these kinds of devices because they become aware of these options. So the last slide here is, I just wanted to put a quick plug in for the Center for Point of Care Diagnostics for Global Health. So we do all kinds of things there. We do evaluation, we do these PDP collaborations, we do training, and that's maybe one thing that might be of interest to some people here. We have 4 levels of courses. It's a didactic course, lab, field, and the fellowship program. And more information is on our website. So it's PATH and then DX Center. And you can sign up for that, and you can get some more information about the training programs that we do. And finally, I'd like to thank a whole bunch of people here who worked on diabetes with me so far up here. And then we have a PATH Diabetes Advisory Board of volunteer advisors. They are extremely valued, and we're glad we have them. Other people from the PATH Diagnostics Group and our funders, NIBRB, Gates Foundation, PATH Fund, the Indian Department of Biotechnology, which has become a funder. It's a sign of the times, but now India is funding us, so it's interesting. And of course, our collaborators, especially those at University of Washington Lab Medicine here, Karen and some of the speakers who've been from Lab Medicine at our training courses as well.
So in diabetes care, serial measurements are really important, and at least when I was in Malawi, people would bring in their little tattered medical record book that may or may not be theirs or may not exist anymore. So can you comment on how you see this data becoming part of the medical record in some way that isn't the patient's responsibility to do so?
I think it has to be biometrics. You know, many of us have laptops with the fingerprint readers on them. It costs about $3, one of those. I mean, the fingerprint reader itself, to add that to a computer. I think it's got to be something like this. And I don't think it's not something that an individual diagnostics manufacturer will have to do. But for example, the standards issue, the Diagnostic Standards Initiative has that as part of the device, is that it's a biometric capture device. I mean, there's of course issues with, like with everything else, there's privacy issues and all kinds of things, but I think it has to be that way.
Thanks for the great talk. The Bill and Melinda Gates Foundation, in one of their more recent call for proposals, seem to really focus on applications of cell phones, and you mentioned cell phones too and how they're very common. Are there devices or approaches that your group is working on specifically that employ cell phones, and like what types of capabilities of cell phones other than just talking or taking a picture maybe?
So we have a group at PATH that works as an mHealth group that deals with cell phone use in medicine in developing countries. So far, I mean, there's a big issue here if you use them as sort of part of your detector in diagnostics, because fundamentally cell phones are not approved diagnostic devices, and they will never be, because the manufacturers will not sign up to that sort of protocol. So how do you deal with, if you make them part of your device function, you got to figure out some way to make them completely independent of the detector that you're using. And there was actually a discussion at this workshop that I mentioned before earlier to you. How would you do that? And so there might be ways to code in some calibration information onto the test itself to make the detector completely independent of your device. But that's sort of a challenge. But really the practical applications of cell phones right now is more along the lines of running algorithms and questionnaires and that sort of thing. That's the practical application. Over time, I see some other applications too. There's an alternative to that. I think that there was a very interesting, I think it was a Nature Chemistry paper where people have used this A1C reader that I just showed before as sort of a standard, or something like this, as a standard device as a detector for all kinds of other things. And because you already, the glucose meters at this point already are so low cost and so universally available that they have all the advantages of consumer electronics in terms of cost and simplicity and so on. And yet they are approved diagnostic devices. So using those instead of cell phones as detectors might actually be more promising.
Continuing on the theme of phones, I was actually thinking of phones as an interface to some sort of local or national health record. Is that an area of research as well? It seems like a natural way in that setting to centralize data.
Yeah, it is being done in small areas, but it's not a widespread approach. I mean, I always thought, for example, if you look at one useful area, one would be to use cell phones to capture, if you don't use them as diagnostic device, but you could use them as devices to capture health records or to capture epidemiological data. For example, people use almost 1 billion strip tests a year in the world. The vast majority of those will never be recorded anywhere. They just disappear from the record. So if you would somehow incentivize people to just take a little snapshot of those, and then it gets uploaded, and every time they get that, they get a free minute of cell phone use or something like that. Out of a sudden, you could conceivably do, with complex algorithms, you could find epidemiological patterns and so on, just based on that information that's being collected. Could be interesting. I mean, I'm not aware of such an effort, but I think somebody should try it.
Are the public health departments and national health departments in the low-resource countries getting more interested in chronic disease such as diabetes?
Yes, in many places they are. I mean, there was this United Nations meeting, NCD meeting 3 weeks ago in New York that some of you probably have heard of. Countries like India and China are very aware of it. They know that economically it's going to just absolutely kill them if they don't take care of it. So I think it's very much in the minds of people now. But there's no solutions really. So that's what people are looking for at this point.